everyone. This is the video for our big idea sessions for week 2 of our class. This will cover 1-1, 1-2, and 1-3, and this is replacing our typical class meeting. Unfortunately, we can't meet in person this week due to the holiday. So I hope you all enjoyed your long weekend, and let's go ahead and get started. And at the end of the video, I'll talk about what you can do with your solutions to upload them and get your attendance points for this week. If you don't have a hard copy of this, you can always print one out in Blackboard as well under the course content for Unit 1. All right, so let's start with what makes something a function or not, because those are going to be our first couple questions here. We're going to look at a table, a correspondence diagram, some points, different ways that we can recognize whether a relation is a function. So it's saying, is y a function of x? When it says, is y a function of x, does it mean that each x corresponds to only one y? Okay, so that's another way that we're going to word that question. Does each x correspond to one and only one y? If the answer is yes, we have a function. If the answer is no, we don't have a function, and then we can use the place where it corresponds to more than one y as a counterexample here. All right, so let's look at our first table of values. Our inputs are our x's and our outputs are our y's. We're looking, does each x have exactly one y in this function? So -3 goes to -7, -1 goes to 1, 0 goes to 5. So far, I have no x's that are going to different values of y. 1 goes to 9, 3 goes to 17. You can even see that none of these x's are even repeating. But when I get to -1, I have a bit of an issue because we already saw a -1 earlier in our table of values. In the first example or point, we had -1 going to the y value of 1. And in the second point, we have -1 going to a y value of -1. So we have one x value, -1, going to two different values of y. So our answer is no. This is not a function, and your counter example here could be -1 goes to 1, and also -1 goes to -1. Okay, let's look at the correspondence diagram. It's the same type of question here. It's just a different way to organize the information. When we have x and then an arrow to the y, it's showing that that x and y go together. So we're looking again for, does one x go to two different values of y? So if you look down at 15 here, 15 is going to cause a bit of an error for us. 15 is directed towards 7. It's also directed towards 9. So no, this is not a function. And again, the explanation could be that counterexample, that x value that corresponds to two different y values. Next, in part C, we have sets of points. Again, just another way to organize this information. So 3 goes to 4, 5 goes to -2. So far, none of my x values are repeating, so we're good. -2 goes to 5, 3 goes to 6, and that's a problem. 3 went to 4, and 3 went to 6. So again, no, it is not a function. And we have a counterexample. Goes to 6. All right, finally, we can have sets of points represented as a graph instead of a table or a correspondence diagram like this last one, letter D. If you have a graph, the easiest way to tell if you have a function, if each x corresponds to exactly one y, is with the vertical line test. So the vertical line test is a visual representation of what we were looking for in those other sets. We take a vertical line, and we're just going to move it left and right on our graph. And we're looking for each x value, or each point that has an x value, does it have exactly one y that goes with it? And as long as this vertical line only touches one part of the graph at a time, then it passes our vertical line test. And you can see this one is only touching the blue line there in one point, no matter where I put it left and right on this graph. So we say that yes, this is a function. And your explanation could be that it passes the vertical line test. Now what this would look like, I'm just going to add a little bit more to this graph. If it did not pass the vertical line test, maybe I would like connect these two pieces, just make kind of this weird shape here. If I did that and I started looking at my vertical line, there would be places on the graph where the vertical line would touch two locations. What that's a representation of are 2 points that have the same x value, in this case maybe an x value of 1, but have different y values, maybe at 0 and at 3 approximately. We're just kind of making some numbers up there, but one x that has two different y's will be 2 points that are on the same vertical line. So that's why the vertical line test will work for our definition of a function. Now the other thing this problem said at the top was to name the domain and range if it is a function. So let's go ahead and do that. To name domain and range, we're going to talk about interval notation, and we'll be using that in the next problem also. So interval notation is where we use brackets to represent equal signs. So if we have a point on a specific location on a graph, we would use a bracket at that value. Parentheses mean not equal to. And when we're talking about domain, we're using x values. When we're talking about range, we're using y values. Domain is all the possible x's on a graph. Range is all the possible y's on a graph. When you're looking for domain, you're going to look left and right, just like your x-axis. When you're looking for range, you're going to look up and down, just like your y-axis. So to start with my domain, I'm going to look left and right, and you can see that this graph does extend to the left and the right. We've got those arrows on either side of it. It doesn't go vertical straight up. It does kind of extend a little to the left and a little to the right. It's going to grow slowly, but it's going to keep moving further and further, both to the left and to the right forever. And then this graph is connected between those two arrows, so there's no location where I don't have a certain x value. I could find a point where I have an x of negative 0.5, or I could find a point on this graph where I have an x of 3.5, or I could find a place on this graph where I have an x of 97 if I made my window big enough. So we say that the domain is all real numbers. This graph is going to go forever left and right without any gaps in our x's. And how we write that in interval notation is like this: negative infinity to positive infinity. The negative infinity means this graph goes as far to the left as you can imagine, and the positive infinity means this graph goes as far to the right as you can imagine. And then the comma just says we're going from one value to the next without any gaps between those numbers. Now the range, we're going to look up and down on this graph. Now my arrows are going up, so we know for sure this guy's going to go up forever, which means I'm going to have a positive infinity, but it does not go down forever. You can see that we have this point where it stops, and then it goes back up and it stays above that point no matter where I look on the graph. That y value, and we're looking at a y value because we're determining range here, is -4. Now because I do have a point at -4, and you would know if you don't have a point there because there would be an open circle on the graph, because I do have a point, it's equal at -4, so we use a bracket. So we see that my range is all the values from -4 and above, which would be -4 with a bracket, to positive infinity. If something went down forever, we would say negative infinity. And usually when you list these numbers, you list them from least to greatest. It's not technically wrong if you flip them around the other way, but it does help when you're reading a graph or looking at a function if you practice going from least to greatest. Also, MyMathLab may mark something wrong if you don't list it from least to greatest. Okay. One thing I do want to mention up here, if we did have a function and we wanted to list domain and range, I'm going to go ahead and do that just in the correspondence diagram problem in B, even though it's not a function, so you can see what one of those looks like. The domain is just all of your possible x values. When you have single x values like this, where you're not on a continuous line, you just list them, and again, from least to greatest, that would be -8, -1, 0, 15, and we use kind of a squiggly bracket to close our set there. My range would be all the possible y values, which are just 7 and 9. And it would look the same if you did the domain and range for part A or the domain and range for part C. You just list all of the possible values. Okay. Let's move down to number 2. Number 2 says find the domain and then write your answer in interval notation. When you're finding the domain, you want to think about restrictions. And I'm going to put these at the bottom here. Domain restrictions. There's two different kinds of restrictions that we might see in our functions. The first is when you have a variable in the denominator. So let's say I would have something like this. The problem with that is x cannot equal 0 because I can't divide by 0. So 0 would be what we call a domain restriction for that function. And it could be, 3 times x or x plus 4. It's not necessarily always 0, but if that denominator equals 0 when you do the calculation or plug a number in, then that value that you're plugging in is considered a domain restriction. So we'll see that in a couple problems on top. The other restriction is if you have a variable under a square root. In that case, we must have a value that is greater than or equal to 0 under the square root. Again, because we can't have a value under there that would give me a mathematical error like we did with the dividing by 0. That's a mathematical error. Having a negative under the square root is also a mathematical error. It gives us something called imaginary numbers, which we'll talk about later on in the semester. So you want to ensure that you have a value that's positive or equal to 0 under the square root, no matter what number you plug in. So these are the two things that we're going to focus on finding domain restrictions. If you don't have any domain restrictions, your domain is all real numbers, negative infinity to positive infinity. If you do have domain restrictions, your domain is all real numbers except for those restrictions. All right, so we're going to look at letter A first here. I've got y equals x to the third minus 2x plus 4. So I want to focus in on number 1, do I have any denominators? No. Number 2, do I have any square roots? No. So this function has no restrictions. So we're going to say our domain is all real numbers, negative infinity to positive infinity. And if you wanted to check that, you could get out your graphing calculator and you could look at a picture of it and see that this graph is going to go left and right forever. Part B, we do have a denominator. So we're going to focus there. Now, a common mistake is when people look at a denominator, they say, oh, x can't equal 0. Well, x actually could equal 0 in this example. If I plug in 0 to that denominator, 2 times 0 minus 8 doesn't make my whole denominator equal 0. It makes my denominator equal negative 8. So what we want to focus in on is what number could I plug in that would make that whole thing equal to 0. And if you're not sure, you can set up a little mini equation. 2x minus 8, that whole denominator, cannot equal 0. And then we're going to solve this. We're going to add 8 and divide by 2. So x cannot equal 4. 4 is the only number, 2 times 4 minus 8, that would give me 0 in the denominator. Every other number would give me some other value in the denominator, which would not be a mathematical error. So my domain is all real numbers except 4. So how we're going to write that, I'm going to show you a little number line here. Imagine my number line. We have an open circle of 4. Maybe I can make it a little better. There we go. And everything below 4 works, and everything above 4 works. We just have to jump over that single number. So we say our domain is negative infinity, remember, is always on the left. Positive infinity is always on the right. Negative infinity to 4 is this first group here. But remember, I'm not allowed to equal 4, so we use a parentheses. Remember, in interval notation, parentheses means not equal to. The other group is 4 to positive infinity. And if you have multiple groups like this, we're going to use a U to connect the two sets, and that just means union. So you can see this really is still negative infinity to positive infinity, but when we get to our single value that's a domain restriction, we're just jumping over that number. That's what this notation means. Okay, let's look at the next one. The next one, we have a square root. And remember, in a square root, whatever's underneath our square root needs to be greater than or equal to 0. So 16 plus 4x must be greater than or equal to 0. And we're going to solve this. We're going to subtract 16 and we're going to divide by 4. And then one thing I do want to mention with these, in inequalities where you have greater than or less than symbols, if you multiply or divide both sides by a negative, you would have to flip the inequality sign. So actually, let me show you what that would look like. If I have let's say it's negative 4x greater than or equal to negative 16. If I divide by negative 4 on each side, I would have a positive 4, and my inequality sign would flip and go the other direction. That's something that you've learned in a previous math class, but it would apply here. So just remember, if you're multiplying or dividing both sides in an inequality by a negative number, that's when that could potentially happen. So that's just kind of like a little side note there. All right, so my domain is all the x values greater than or equal to negative 4. Those are all the numbers that I'm allowed to plug in that won't give me a negative number. And how you could check that is you could plug in like negative 5. If I plugged in negative 5, I would have 16 plus negative 20, which would give me a negative under my square root, which would cause a mathematical error. So that makes sense with the answer that I've got here, that that's going to work for my domain values. Again, you can think of the number line if you're not sure how to put this in interval notation. My x values, my domain is negative 4 and a closed circle because I'm allowed to equal it. That's what that little line means. And everything above it. So how we put that in interval notation is negative 4 with a bracket because it's a closed circle all the way up to, on the right side, we use positive infinity. And you'll notice every time I'm writing infinity, there's always a parentheses next to it. Infinity is not a number. It's this idea that we approach, a limit that we're getting close to as we get larger and larger or smaller than smaller. So because we can't ever actually equal infinity, we always use a parentheses. Finally, the last one here, we have kind of a combination of the two. I have a denominator and I have a square root. So that means because it's a denominator, it can't equal 0. And because it's a square root, it has to be greater than or equal to 0. Well, it can't be equal to 0 and not equal to 0. So what we do in this case is we say x plus 3 is strictly just greater than 0. Whenever it's a square root, we always say greater than or equal to unless it's in the denominator, because a denominator cannot equal 0. So this is going to be very similar to the previous problem and how we solve it now. We're just going to get the x alone. X is greater than negative 3. So my domain is all numbers bigger than negative 3. And then it's going to, again, look very similar to the last one. Negative 3 to infinity. Infinity always has a parentheses. Here, because it's strictly just greater than, not equal to, we use a parentheses instead of a bracket when we list our interval notation. All right, that's all we've got for page 1. Let's move on to page 2. Our next problem is evaluating a function. This is what we call function notation. A lot of times you'll see f and x, but it could be something else. It could be g of n. The variable that you see inside the parentheses here, that's our input. I can squeeze it in there. That's our independent variable. That's what you're going to be plugging values in for. And again, a lot of times it's going to be an x there. F is just the name of the function. We say this is function f, and the function is 5 plus 2x minus x squared. So when I see f of negative 2, that's telling me x is negative 2. Notice that's the only two difference between these notations here, is the x has been replaced with a negative 2. So we do that in our function. On the right side, everywhere I see an x, I'm going to take it out, and in parentheses, I'm going to put negative 2 in its place. Now you can use your calculator at this point if you want to. You can type that whole thing in exactly as you see it, or you can use your order of operations like we practiced last time. I would do negative 2 squared first, the exponent, which gives me 4. Then I would do any multiplication or division from left to right. So 2 times negative 2 gives me negative 4. And then I really don't need those parentheses. I can just say minus 4. And then we're going to do our addition and subtraction from left to right. So 5 and negative 4 give me 1. Minus 4 again gives me negative 3. So we say that f of negative 2 equals negative 3. And that actually tells us that negative 3 that we're getting out is a y value. It tells me the point negative 2, negative 3 is on this graph. If we were to look at the graph, we would see that x and y coordinate that go together. So that's what we're getting out when we're evaluating these, a y that goes with an x value. Okay, the one in the middle, we have 6y being plugged in for x. So same strategy here. Everywhere I see an x, I'm going to take it out and this time put 6y in its place. So again, this is going to be a little review from our previous class. If I have an exponent next to a parentheses, this was one of our exponent rules. We're going to distribute it in, and imagine that 6 and y both have a little power of 1 there. Keep that negative outside. I would have a 6 squared, which is 36, and a y squared. The next thing I can do, I can multiply 2 times 6y, which gives me a 12y, minus 36y squared. And then I don't have any like terms, so this could be our final answer here. We're not going to get a nice pretty number out because we plugged a variable in for another variable, but we can reorder it into our standard notation. Negative 36y squared, that would be the highest degree terms. We're going to put that first, plus 12y plus 5, and that would be your final answer. Finally, for the last one, we're going to plug 4 minus u in for x. So 5 plus 2 times 4 minus u minus 4 minus u squared. So again, review from last time. Anytime we have a parenthesis squared with a plus or minus in it, we are FOILing. And in this middle term, I'm going to go ahead and actually just distribute my 2 in, make it 8 minus 2u. Bring down my minus, and now I'm going to FOIL. Now, if you need to, instead of writing 4 minus u squared, you can write, remember that parentheses, times itself. Okay, 4 times 4 gives me 16. My outside terms, 4 and negative u, give me negative 4u. My inside terms, negative 4u. And then my last terms, negative u and negative u, are a positive u squared. Now, notice I put all that in parentheses because that minus in front still applies to everything after it. So the next thing we have to do, think of that like a minus 1 that's hanging out there, is we have to distribute that negative into that parentheses, which means it's going to change the sign of everything in my parentheses. So I'll bring everything out front down. Then I'll have minus 16 plus 4u plus 4u minus u squared. And then finally, you can see we have a lot of like terms here. So I'm going to combine those together, and I'm just going to kind of mark them as I go so I don't forget anybody. I have a negative u squared. No more of those. Then I have a negative 2u, a 4u, and a 4u, which give me a positive 6u. And then finally, I have 5 and 8, which is 13 minus 16, negative 3, and that would be our final answer. The last thing we're going to talk about from section 1.1 is how to evaluate functions when you have a graph. So remember I talked about a little bit ago in the last problem is the number inside the parentheses is the x, and when you plug it in, whatever you get out is the y. So here we have function g, and they are kind of giving you included the notation at the top there. I'll write that a little bit bigger. Y equals g of x. So what's inside the parentheses is an x, and what's outside the parentheses is a y. So if I'm looking at letter A here, I have half of a point. My x is negative 3. My y, what this is going to equal, is what we're missing. So we're going to go to our graph and see if we can find it. Find an x coordinate of negative 6. That's right there. And then to find the y that goes with it, you're either going to go up or down. In this case, I have to go up to hit the graph, and I have to go up 1 unit to hit the graph. So g of negative 6 is equal to 1. And so if you were doing this in MyMathLab, 1 would be your final answer. That 1 is the missing part of the coordinate. The one below it, it says find x when g of x equals 3. Now this means I have a y coordinate of 3, and the x is what I'm finding. So we're going to use our graph a little backwards. Now I'm going to start on my y-axis, and then I'm going to look left to right. In this case, the graph is to the left. I have to go 2 units to get to my graph, and then you'll actually notice if I keep going, there's one other place on this graph where we have a y coordinate of 3. That occurs at negative 2 and also at -4. So we have 2 points, -2, 3, and -4, 3, that have y coordinates of 3 on this function, and so then your solutions are x equals -2 and x equals -4, and those are the two values that you would type in MyMathLab. All right, so that was our summary of 1-1. Moving on, 1-2, I'm going to need my graphing calculator, and so are you, so I'm going to pause the video real quick, get it, and then we'll continue on. Okay, so here we're going to practice a little bit with our graphing calculators. We're going to graph this function in the standard graphing window, and then we're also going to graph it in a new window, which they're specifying what we want that window to be, and see which one is a better fit to start here. So to graph that in your calculator, we're going to go to y equals, top button on the left there. If there's anything in there, hit clear. Your plot may be on. If your plot is highlighted like this, that means your plot is on and you don't want that. So we're going to go up, hit enter, go back down so nothing is highlighted. All right, let's put that equation in. X to the fourth, and remember last time we met we talked about this little arrow above the division key will help us with our exponents. Arrow to the right to get out of that. -3. Notice every time I'm pushing an X, I'm using the button next to alpha. That's our variable button. That's where there's a bunch of different letters on it. To the third power, plus 5x, plus 1. Now to graph in the standard graphing window, you can either hit graph, which it might be in that window already, or if it's not, if it doesn't look like that, you can hit zoom, and then Z standard means the standard graphing window. So zoom 6 is a quick shortcut for that. And then that's what the graph looks like. So just on your paper, you can sketch this, and I'm going to go ahead and just drag it over because I can do that on mine. Get rid of that. Go away. All right, so there's our first one. Now we're going to do the same thing. We've already got that equation in there, but we're going to change the graphing window. To change the window, hit Window right next to y equals and use the values that they're listing. So where it says x min, we're going to hit -5, arrow down. X max is 5. Y scale and X scale, we're just going to leave those alone. Y min, -2. Y max, 12. And those are the only things that we had to change. Hit graph. And you can see there's the same graph. And we've just got a different zoom window that we're seeing it graphed in. So the question is, which is a better fit? And hopefully you agree with me that the second one gives us a little bit better picture of what's happening at the turning points and whatnot in this function. So I'm going to say graph B, if they're lettered here, is our better fit graph. Now we're going to use our calculator to find turning points. Again, to find turning points, you want your equation in y equals. You'd also want it graphed in a nice window. Either window that we tried earlier would work. I'm going to keep it in this window for now. To find turning points, we're going to hit second trace. This is our calculate menu. You can see calculate above it on the button there. We're going to use this a lot. Turning points are minimum and maximums. They're low and high points on the graph. So we're going to start with maximum. I'm going to go to number 4 and hit enter. Now a maximum point is kind of like the top of a hill. Anywhere that your graph changes from going up to going back down as you follow it from left to right. And the maximum we're looking for is right in here. So to find it, we're going to use our arrows, and your calculator kind of gives you directions at the bottom here. It says left bound. So you just want to move the little, I don't know, blinking cursor, turtle, whatever you want to call him. So he's on the left side of the hill, kind of close to the top, but on the left side of the hill. Doesn't matter exactly where. Once he's close to that, hit enter. Then the calculator says right bound. So we're going to go on the right side of the hill. Not at the top, not too far away, on the right side, hit enter. And you'll notice we get 2 vertical bars that show up and little arrows pointing towards that maximum point there. So that's what you want, is your high point is located between those 2 bars. Finally, your calculator tells you to guess. So we hit enter, and it tells me the maximum is 0.999999, so we're going to say 1, 4. So let's go ahead and list that one first. Just Just rounding that a little bit. Next, we're going to find minimum values. These are low points. Think of them kind of like the bottom of a valley. We have two of them. There's one on the left and one on the right. So we're going to need to complete this procedure twice. Starts out the same. Go to your calculate menu above trace. This time choose minimum, number 3. I'm going to start with the one on the right because I'm kind of over there already, and it's going to ask me the same 3 questions. Left bound, right bound, enter. I'm on the left side of the valley. Hit enter. Arrow over to the right side. Hit enter. And then finally hit enter one more time. And I'm going to round to, let's say, I don't know, 2 decimal places. So 1.91 and 2.95. And then we need to do it one more time. Second, calculate, minimum. And then we want to go over to the other little valley that we've got on this graph. First thing I need to be is on the left. Oop, I went too far. Here we go, on the left side of it. Hit enter. The right side of the valley. Enter. Enter one more time. Again, around to 2 decimal places, negative 0.66 and negative 1.25. So that's how we get turning points, minimum and maximum values. Finally, we want to use the calculator to find the value of y when x is 2 and x is negative 10. Now there are a couple different ways to do this that I talked about in the Edpuzzle video. Honestly, guys, the easiest way to get it is to go to your table. Second graph, table, and you're just going to look for where x is 2 and x is, what was the other one I was looking for? Negative 10. So you can see when x is 2, my y is 3. When x is negative 10, I get 12,951. So let me see if I can, well, let me write that one down. 12,951, I think it was. And the other one, when x is 2, it was y is 3. Now, let's say you want to find the value of y when x is like 1,000,000. You don't want to scroll here forever. So what you can do is hit second window to your table set, and you can make your table start at whatever you want. So I could make my table start at, I don't know, 1,000. And then when I go to table now, second graph, I'm at those really big numbers without having to scroll that far. And if you want to go back, second window, takes me to my table menu, and then our default is usually we want our table to start at 0. And you can see now I'm back to where I wanted to go. That's also a great little trick if you scroll too far and you don't want to get back. So you can also do that in the calculator on the graphing screen. You can hit calculate, value, and then I can type x is 2, and it will tell me y is 3. The only downside to that method is you must have the point in your viewing window to be able to let the calculator calculate it. So you would have to zoom out pretty far to have the x value of negative 10 be at like 12,000 something. So it's nice to be able to look at just the table instead of the graph, but you can find it on the graph as long as the point you're looking for is within the window that you see. If you guys need any extra practice or troubleshooting with your calculator, please, please, please come to office hours on Wednesday night, 6 to 7 in Blackboard Collaborate. There's a link for it in our Blackboard course, and I can help you kind of walk through some steps in your calculator. There might be a setting that's on there from whoever had it before, or if you had a previous math class, and I might be able to help you get it reset so everything's working for you. All right, the next thing we're going to do from section 1-2 is just practice graphing in our calculator, getting a table of values. Now here it says we want to use the integers negative 3 to 3 for our x's. We're going to use that for both graphs, so I'm just going to go ahead and fill those in now. Even if it didn't say to use those numbers, these are nice little starting values. They're not too big, not too small. Then we plug them in, and you can plug them in by hand. We'll do one by hand here. and it's the order of operations. So we would do our parentheses first, which would give me -1. Then I square that, that gives me +1. Then I multiply by -4, that gives me -4, plus 4 would actually give me 0. You could do it again with another one. Let's say I plugged in -2. -2 plus 2 gives me 0. Squared is still 0. Times -4 is still 0. Plus 4 gives me 4. If you want to, in your calculator, use that to fill your table, you can just hit second mode. That takes you back to your home screen. That's our quit option. And we can type them in. Let's say I want to type in -1. -1 plus 2, parentheses. You can either use the arrow and square it, or there is a shortcut for squaring right next to the comma. Plus 4 equals 0. Let's plug in 0. Here's a trick. If you have to type in the same thing over and over again, hit second, enter. That is entry. That will bring up the last thing that you had typed in, and you can use your arrows to edit the number. So I'm going to delete out the negative and just put a 0 in there. Enter. Gives me -12, so that's kind of nice. Another way to fill this table out is I could go to y equals. Clear out my equation I have, and let's put our equation in. Remember that f of x just means y, so y equals is already there, -4 parentheses x plus 2 parentheses squared plus 4. And now I can look at my table, second table, and I can scroll to whatever numbers I want. This is probably the fastest way to get what you're looking for because it does everything at once for you. -1 is -32, 2 is -60, and then what was 3? -3 is -96. Now, of course, some of these aren't going to fit on my graph, but let's graph what we can. Remember, when you graph, x is first, y is second, left and right first, up and down second. -3, 0, -2, 4, -1, 0, 0, -12 is going to be a little off this graph, and then it's going to go down forever. Anytime you have a squared in your graph, we call that a quadratic, and we're going to learn a lot more about those this semester, and it gives you kind of this U shape. It is called a parabola, and that's a terrible U shape. You guys get the idea, but it is called a parabola, so expect that U shape out, either going up or going down when you have an equation that looks something like that. Now the one next to it is an absolute value. Absolute value, again, you can plug these in by hand. 3 times -3 plus 6. Well, 3 times -3 would be -9, plus 6 would be -3. We treat those absolute value bars like parentheses. We do everything inside that first. And then absolute value means distance to 0. So the way a lot of people remember it is it just takes whatever's inside the absolute value bars and it spits out a positive number. If it's positive, it stays positive. If it's negative, it becomes positive. So when I plug in -3, I get 3. Let's say I plugged in -2. 3 times -2 is -6. Plus 6 would give me 0 inside my absolute value bars, and the absolute value of 0 is 0. You can also type it in your calculator. Let's go back to that home screen. Second, quit. To get absolute value in your calculator, you hit math, and then if you arrow to the right, it says NUM, that's our number menu, and the first thing there is ABS, absolute value. And if you have an older version of the calculator, it might just say ABS parentheses, or if you have the newer version, it'll look like mine. But either way, you can put 3 times the number, -1, that we're plugging in next, plus 6. And you can see I get an answer of 3. My calculator again, remember we can hit second, enter, and we can change it. I'm going to delete out that negative and just put a 0 in. Gives me an answer of 6. You can also put it in your y equals, so it'll show up in table. Y equals. Clear out what you have. Let's get that absolute value sign again under math. Arrow to the right to the number menu and hit enter. 3x plus 6, just putting our equation in. And then second table to see my table of values. So what are we looking for? 1, 2, and 3, 9, 12, and 15. Okay. Negative 3, I'm at 3. Negative 2, I'm at 0. Negative 1, I'm at 3. 0, 6, 1, 9. And again, we get to a point where it's going to go off my graph. Absolute values make almost a U shape, but it has a sharp corner at the bottom. It makes a V shape. If you want to check that in your calculator, we already have that equation. Put in a y equals. You can hit graph. Now remember, we had changed our window a little bit for that previous graphing problem. So I'm just going to go back to my standard window, zoom 6, and you can see a picture that matches what we see on our graph there. Make sure when you're graphing by hand that if your graph continues in one direction that you want to extend that line as far as you can in that direction and put an arrow at the end of it to show that it does not stop. Oh, we do have one more from 1, 2 here. We're going to make a scatter plot. All right, so let's review how to do that in the calculator. We're going to hit Stat right next to our arrows. We're going to hit Edit, and we're going to get this data in there. Now, I've already got the data in there, as you can see. If you have other numbers in here that are not these, you're going to go up to the list name. I'll actually show you with this name one. Hit Clear and go back down, and that will clear out your list. You should have an L1 and an L2. If you do not have an L1 and an L2, do this right now. Hit Stat, 5, Enter. And now when you go back in, you can see you should have an L1 and an L2. So L1 is your default X's. Just start hitting your numbers, hit enter, or you can arrow down to go to the next line. And then arrow to the right. You can get all those Y values in there, so go ahead and take a second to do that. Okay, so once you have your data in there, we want to find a scatter plot with our calculator and then find a line of best fit and put it on the same axes. So to do that, we're going to go to y equals. Let's clear out that equation we had from earlier, and we want to turn our plot on. So I'm going to go up, hit enter, go back down, and now my plot is on. To see the scatter plot, we're going to hit zoom and then zoom stat. So anytime you're graphing statistics data, you're going to hit zoom 9. Remember, zoom 6 was our standard window if you want to go back. So zoom 9, and we're going to see a nice picture of this scatter plot. Now what it wants us to do is find the line of best fit that goes along with the scatter plot. To do that, we're going to go back into stat. This time we want the calculator to calculate the line that represents this data. So we're going to go to the right where it says calculate. And then we're going to use quite a few of these this semester, but for right now we're just worried about a line. A line is number 4 that we're looking for. It stands for linear regression. A regression line is a fancy term for a line of best fit that'll show us the trend in this data. So we're going to hit number 4, and then you can see it's using the L1s for X's and the L2 for Y's. Nothing you need to change there. This next step is optional, but it'll save us some time in a second, so I'm going to show you how to do this. We can store our equation the calculator is going to find in y equals, so it'll automatically graph it for us and we don't have to retype it in later. To do that, you're going to hit vars right below your arrows, arrow to the right, y vars, function, and then y1, or any y, actually, it doesn't matter, but I'm going to use y1. And then we calculate, enter. Now your calculator might not have R's there, that's not a big deal, but you should have A's and B's, so that's what we're looking for. So that means, I'm going to drag this over so I can write on it. Our equation, we're going to fill in that a and b, is y equals, a is negative 2.83, I'll round to 2 decimal places in front of the x, plus 88.73. Now, in your calculator, if you go back to y equals, you will see your calculator has put all of those numbers in for you. You don't have to type them in, which is amazing. And if you hit graph, you will see a picture of the scatter plot with the line, the trending line, the line of best fit, the line of regression going right through your data values exactly as it should. Finally, we're going to use our line to estimate the grade if you have 12 absences. Now, absences in our data are the x's. So when we say 12 absences, 12 is going to be plugged in for x. You can estimate this on the graph if 12 is on the graph. I don't think it is in this picture. You could also estimate it from the table. We did that before. Hit second table and find 12. Or you could just plug 12 into your equation for x, whatever works for you. I'm going to use the table because it automatically calculates it for me. When x is 12, y is 54.8. So we're going to say that is our final grade. 12 absences, we have a y of 54.8 would answer that question. Okay, so we got our scatter plot from stat menu, stat edit, we put our data in. If we went to stat calculate, we could do the line of regression, and then we can evaluate our equation once it's in y equals, or just plug the number in from that. Okay, so if you need to rewatch any part of this little, I don't know, tutorial for number 7 here, you can always just rewind, go back, write down the buttons that I hit as you go through. That might be helpful, especially when you're coming up to like your next quiz or test when you're studying, that you can locate things in your calculator quickly. And again, if you're having any calculator trouble, please hop into office hours on Wednesday from 6 to 7 and I can help you guys out a little bit. Last lesson for this week was section 1.3, linear functions. So you guys probably did a lot with linear functions before. We get a little bit more involved with them back in like algebra 1 and algebra 2 in high school. We're going to start with x and y intercepts. X and y intercepts were points on your x or y axis. That's what we're looking for. Any point on the x-axis will have a y coordinate of 0, something like that. And any point on the y-axis will have an x coordinate of 0. So that's actually how we calculate x and y intercepts. If I want to calculate an x-intercept, I know its y is 0. So what I do is I plug 0 into the equation for y. Well, anything times 0 is 0. And then divide by -7. I'm going to get a positive 12. So you could say the x-intercept is 12, and then sometimes we write it as a point, x12, y0. If I want to get a y-intercept, plug in 0 for x. -7 times 0 is 4y equals -84. Again, anything times 0 is 0. It's going to go away. Divide by 4 gives me -21. So 0, -21 is my y-intercept. Finding slope between lines, or between points to get a line. Slope formula from the lesson, y2 minus y1 over x2 minus x1. So for letter A, y minus y, it doesn't matter which y I start with, so I'll do it both ways here to show you guys. Let's say I start with this y. I'll do 6 minus 2. And then x is on the bottom. Now if I started with 6, if I started with that point, I also need to start with that point in the denominator to keep that consistent. So -9 minus negative 1. 6 minus 2 gives me 4. Negative 9 minus negative 1, which is negative 9 plus 1, negative 8. And then this is just order of operations. We talked about this last time, right, guys? We simplify the numerator, simplify the denominator, divide last, and this would give me negative 1/2, or if you said negative 0.5, that's good. Let's do the one on the right. Y minus y. I'm going to do negative 5 minus negative 5. This time, if I started with the right, I do the same thing on the bottom. Negative 2 minus negative 4. Negative 5 minus negative 5 is like negative 5 plus 5, so I actually just get 0 on the top. Negative 2 plus 4 on the bottom gives me 2. 0 divided by anything is 0, so we have a slope of 0. Now, if your 0 is in the denominator, remember you cannot divide by 0, so we would say that the slope is undefined. Let's flip to the last page. There we go. Next thing we're going to do is find the slope and y-intercept of this line. So let's start with, well, you know what? Let's go ahead and just get the y alone. So we're going to talk about this more in future sections, but y equals mx plus b gives us our slope. It's going to be the number in front of the x, and the b gives us our y-intercept. You could also find the y-intercept by plugging in 0 for x, like we did in that previous problem. But if we can get the y alone, we can kind of find both at the same time. And when we say get the y alone, we mean isolate y. We mean move everything that's on that side of the equation away to the other side of the equation, so y is the only thing left. And how we do that in a linear equation, where we're dealing with lines, is we move the x term over first. Now, this x term is positive, so I'm going to subtract that x term on both sides. Positive and negative will cancel. That leaves me with negative 4y equals 22 and negative 12x are not like terms. One has an x, the other does not. So all we can do is put them next to each other, like so. The next thing we do to get the y alone is we get rid of the number in front of it. Now, negative 4 is multiplied by the y, so what's the opposite of that? We divide. And we're going to divide everything in this equation by negative 4, so that keeps my equation balanced. On the left, my negative 4's cancel, leaving me with y. On the right, I can simplify. 22 and negative 4, those are both divisible by 2, so I can make it negative 11 over 2. Negative 12 divided by negative 4, that actually divides in evenly. It's positive 3 in front of my x. Now, you'll notice this looks really similar to our slope-intercept form over here, but the x term isn't first, so this is an optional step, is you could switch your terms around. The 3x first, the negative 11 over 2 second. And then you can easily see that your slope is 3, just the number in front of the x, and the y-intercept is the number that's all by itself, our constant, negative 11 over 2, or you could say negative 5.5. All right, let's do some graphs of lines. These two are already graphed for us. We want to find the slope. So slope, we had the formula a minute ago, y2 minus y1 over x2 minus x1. That means change in the y's, or change in the height, divided by change in your width. So a nice way we say that is rise or run. Now, rise can be a rise or fall, can go up or down, depending on which way our line is going. But when we run, we always run to the right. So when we're going to read the slope of a line that's already graphed for us, we're going to go from the left to the right. And I'm going to use the points that are labeled here already. The first thing we figure out, is it rising or falling? Well, this line from left to right is rising, so we know it's going to be a positive. We want to know from one point to the next, how much do I have to rise? So you can just count. We're going to make a little triangle here. So I have to go up 2, and then I have to go to the right. You can count it 3. So my slope is a positive 2/3. Now let's do that with the next one. Again, we're going to go from left to right. First, am I rising or falling from left to right? This graph is going down from left to right, so it's a negative slope. Then we count, how much do I go up or down? In this case, we're going down 1, 2, 3, 4 units. And then I have to go to the right 1, 2, 3, 4, 5 units. And neither of these reduce, so this would be our final answer. Our slope is negative 4/5. Last but not least, let's graph some lines. The first two cases are special cases. If you have x equals a number, you have a vertical line. And if you have y equals a number, you have a horizontal line. To graph x equals 4, we find where x is 4 on our x-axis, and then from there we draw a line up and down, vertical. It has that equation because every point on this line, no matter where I pick one, has an x coordinate of 4. Y is -2. We make a point at -2 on our y-axis, and we draw a line left and right. Again, it has that equation because every point on this line has the same y-coordinate of -2. Letter C, y equals -4x plus 5. This is that slope-intercept form. We wrote down earlier y equals mx plus b, where my slope is the number in front of the x, -4, and my y-intercept is the number by itself, my constant 5. We're going to make a point of 5 on my y-axis. So on my y-axis, 1, 2, 3, 4, 5. We always do that first. And then second, from that point, we use our slope. Now we need to have a fraction, a rise and a run. So if you have a whole number like this one, you can think of it as over 1. Because it's negative, remember that means we're going to go down. So we're going to go down 4, 1, 2, 3, 4, and then we always run to the right. There's another point on that line. You can do it a couple times. 1, 2, 3, 4, run to the right. And then you can connect the dots. Oop, that's a bad line. There you go. And there's your line. If you want to check it, you could do that in your graphing calculator. I'm going to hit y equals, and let's just kind of reset a couple things here. Let's turn that plot off. Go up, hit enter, go back down. Let's clear out what we have in y equals, and let's put our equation in. -4x plus 5. And then I want to just graph this on the standard window, so zoom, 6. And then you can match that. Of course, the line on the calculator is a little straighter than mine, but you get the idea. You can match that with the line you've drawn to make sure it makes sense. If you do not have the y alone in an equation, you have two options to get the graph. Option number 1 is you can solve for y, as we did earlier, to find the slope and y-intercept. Option number 2, which is what I'm going to do, I think it's a little easier, is to graph using intercepts. Find the x-intercept and find the y-intercept, and then just plot those 2 points. Again, remember, x-intercept is when y equals 0, y-intercept is when x equals 0. So to get the x-intercept, plug in 0 for y. That gives me -3x equals 24, because anything times 0 is 0. Divide by -3, I get -8. So that's a point on my line, -8, 0. I can actually graph that on my x-axis. I have a point at -8. Y-intercept is when x is 0. So let's plug in 0 for x. 4y equals 24 when that 0 goes away. Divide by 4. Y is 6. So that point is 0, 6. I need to scroll up to be able to get to that. 1, 2, 3, 4, 5, 6. And there is our line. This one is a little hard to check in the graphing calculator because the y's alone, anytime you put equations in y equals, your y needs to be alone. So if you did want to check this, absolutely possible, but you would have to move the 3x over to the right and divide by 4 to be able to get the y alone, to be able to type it in the calculator. So again, that's another way to graph it too, is you can get the y alone and then graph using slope and y-intercept, and that maybe would be easier to check in a calculator if you want to go that route. Okay, so that is the end of our big idea session for week 2. So now what I need you guys to do is take pictures of what you've drawn in your notes, all your graphs and your equations, and get them into a single file. So options to do that is you can use something like PDF Scanner. We talked about in class, the Notes app, if you have an iPhone, is a great way to get them all into a single document. Another option is you can take 4 separate pictures and put them all into a single document, like with Microsoft Word or Google Docs, if you're familiar with that, and then submit that one document. So once you've got all of your pages into a single PDF document, please then go into Blackboard, go into Unit 1, where it says Big Ideas in our folder, and you will see an option to upload your work. And as long as you've got all your notes written down for today, you're going to get full credit for your week 2 attendance. And then don't forget to check out the WAG for this week, what you guys can be working on. Remember that quiz I gave you last time, you're going to turn that in by hand on Monday the 13th. And then you have no other quizzes this week, but you will have one upcoming next week after we're back in class. So you can be, working on your Edpuzzles that are coming up. You can work on those MyMathLab assignments. Don't forget to email me questions with MyMathLab or pop into office hours if there's anything that I can help with on Wednesday night from 6 to 7. Have a great week, guys, and I will see you next Monday.